Hey guys, today we're going to talk about translating expressions and equations. So essentially we're going to be talking about word problems. So right now we're actually on the notes for 8A. So day 8, it's 8A. First off, an equation is actually a mathematical sentence that represents two expressions that are equal. So on either side of the equal sign we have an expression. Okay. When you see the word quantity, as a reminder, you must use parentheses. Okay. All right. So for instance, and then let's see, we're going to look at this first example, but before we do that, when defining a variable, we're going to do something called a let statement. Okay, and this should make sense. All right. And this is going to be important. I'm going to be doing this for every problem. So the first example says to translate the following and solve. The quotient of the quantity 5 minus a number and 7 is 4. Okay, well, where do we begin? It says the quotient of the quantity 5 minus a number. So this number, do we know what this number is? Okay, we're actually looking for the number. So because the number is the variable, let's let n be equal to the number. All right, I like my variable to start with the letter that we're looking for, meaning n is the beginning, is the start of the word number. So we're going to write an equation. It says the quotient of the quantity. So if we have the quantity 5 minus a number, so the quotient would look like this, a fraction bar, because that's division. The quantity 5 minus a number would be 5 minus the number, okay? Okay, and 7, so we'd say and 7, we read it like that, it would be equal to 4. So there's our equation right there. Okay, so 5 minus n divided by 7 is equal to 4. So to solve this equation, we could do it two different ways. You could think of cross products and maybe multiply 7 times 4 and 1 times 5 minus n, or let's just get rid of the fraction on both sides. We learned how to do that last class. So let's multiply both sides by 7. So when we do that, we've got these two 7s would cancel out, and we're left with 5 minus n is equal to 4 times 7 is 28. So if we subtract 5 from both sides, we end up with a negative n is equal to negative 23. And then when we divide by our negative 1, n is equal to 23. Okay, so we just found that number. The number is 23. Okay, so this was the first example. Let's go into some of these numbers that we're going to translate and try to solve. So Marie bought 12 pieces of fruit, of which there were X apples, 5 fewer oranges than apples, and 1 pineapple. How many apples and oranges did Marie buy? Well, I want to change something. Instead of X apples, I'm going to change my variable to be A, okay? I prefer to have my variable start with the letter, okay? So apples would be A. So my let statement would actually be let A be equal to apples, because that's what we're starting out with. We're trying to find how many apples and oranges. So our variable is A is equal to apples. Now we're going to be writing one equation. Keep in mind, one equation means that we're going to have one variable. We only have one variable. So when you're looking for oranges, don't think, oh, I need to have a variable O. No. What you need to do is actually write an expression that represents oranges relative to apples. So if there are A apples and there's 5 fewer oranges, what expression would represent 5 fewer oranges? It would be apples minus 5. Okay, so see how we can use the same variable? Okay, it's just that oranges is the apples minus 5. And 1 pineapple. Well, the pineapple is just 1, so that's a constant. So the pineapple would be 1. So we have our apples, our oranges, and our pineapple. And it says, how many apples and oranges did Marie buy? Okay, well, we know that the total amount of fruit is going to be 12 pieces of fruit. So our 12 pieces of fruit right here, we've got 12 pieces of fruit. We're going to write our equation right now. We're going to take our apples, okay, we're going to add our oranges, okay, and then we're going to add, so this is our apple. This represents our oranges, this expression, okay, and then our pineapple, and that's going to be equal to 12. Okay, so there's our equation. Now we use everything we've learned, okay, about combining like terms. So we have 2a minus 5 plus 1 is minus 4, and that's going to be equal to 12. We add 4 to both sides. We get 2a is equal to 16. We divide by 2, and our a is going to be equal to 8. So by naming this variable a, I know immediately that I found how many apples I have. So I have 8 apples. Now to figure out how many oranges I have, I simply take the 8 for a and plug it in. And I have 8 minus 5, so I have 3 oranges. So 8 apples and 3 oranges. And of course, I have my 1 pineapple. All right, so the question asked, how many apples and oranges did Marie buy? There's my answer. Okay, and I do a quick check. Did I add up to 12 pieces of fruit? Yep, 8 and 3 is 11, 1 is 12. Okay, so a lot of our word problems actually have money in them. So that's why we'll be using decimals, and that's fine. Okay, cucumbers cost 15 cents each and tomatoes cost 9 cents. Mom buys 6 more tomatoes than cucumbers. All right, All right, so let's think of our let statement here. Do we know how many cucumbers Mom bought? No. Do we know how many tomatoes? No, but we know that she bought 6 more tomatoes than cucumbers. So let's let C be our cucumbers. Okay, and if C is our cucumbers, our tomatoes, we can actually come up with an expression for tomatoes. It would be cucumbers plus 6. Okay, because Mom bought 6 more tomatoes than cucumbers. So once we have our expressions here, both with the same variable, we can actually see how much each one costs. So cucumbers are 15 cents each. So writing our equation, that would be 15 cents per cucumber, and tomatoes cost 9 cents each. So that would be times 6C plus 6, because tomatoes are C plus 6, and we can't forget to distribute that. And her total bill is $1.26. So we just set up the equation. And now working with decimals is the same as working with whole numbers. We still need to first distribute. So we've got 0.09C plus 0.54, and that's still going to be equal to $1.26. We still combine our like terms. So 0.24C plus 0.54, and that's going to be equal to $1.26. And then we subtract our 54 cents from each side. Okay, when we do that, we've got 0.24C, and that's going to be equal to 0.72. And then we divide by 0.24, and we end up with our C is actually equal to 3. Okay, so if C is cucumbers, we know we have 3 cucumbers, and tomatoes would just be 3 plus 6, which would be 9. So our answer would be 3 cucumbers and 9 tomatoes. Okay, always make sure you answer the question. Okay, number 3. Jack is 25 years younger than his mother. Together their ages add up to 89. Find each of their ages. Okay, well, we know that Jack is 25 years younger than his mother. Do we know how old his mother is? No, so let's let M be his mother. Okay, and you could have let J be Jack. Okay, and then, so if M is the mom, then Jack would actually be 25 years younger, so the expression that would represent Jack's age is Mom minus 25, okay? We could have done it another way, too. We could have actually said, let J be equal to Jack, and if we did that, then Mom would be actually equal to J plus 25, okay? And it would work out to be the same answer, so it's your preference, okay? So now it says together their ages add up to 89. So if I take Mom and I add Jack, I should get 89. Okay, again, that's Mom right there. And the expression for Jack is M minus 25, so that's Jack. All we did was add them together. All right, we combine our like terms. 2M minus 25 equals 89. And then we add 25 to both sides. When we do that, we get 2M is going to be equal to 114. When we divide by 2, M is 57. So now remember, because it's an M, we know it's Mom. Mom is 57. We subtract 57 minus 25 to get Jack's age, and we get him to be 32. So Mom is 57, and Jack is 32. Okay, that's the answer. Now notice, had I done it the other way, okay, and I had Jack be J and Mom be J plus 25. Again, if I add them up, let's make this be red. Okay, J is not cooperating with me. Okay. Okay, this would be j plus 25, and that would be equal to 89. In this case, we have 2j plus 25 is 89. Okay, and I would subtract my 25. All right, when I did that, 2j would be equal to 64. So when I divide by 2, Jack is going to be 32. So see, we get the same answer, only now we take it and we would add 25 to get Mom. So you can do it either way. It doesn't matter. You're going to get the same answer. Okay, number 4. Lorene has some nickels, twice as many dimes as nickels, and half as many quarters as nickels. All total, she has 77 coins. How many of each? How many does she have of each? So, in this case, our let statement is going to be, let's look at this. We don't know how many nickels she has, but we can write an expression for dimes as twice as many nickels, and quarters can be half as many quarters. So let's let n be our nickels. Okay, so once we know our nickels, our dimes, we can write an expression for dimes. It's twice as many, so we're going to take 2 times the number of nickels. And then quarters would actually be half as many. It says half, so you could say n divided by 2, or you could do 1/2 n, either way. All right. All total, she has 77 coins. So if we take our nickels, we add our dimes, and we add our quarters, we're going to get 77. Okay, we combine our like terms, and we've got 3.5 n equals 77, and you could say 3.5 n if you wanted to. Make it easier to divide by the calculator. And when you do that, you're going to find out your n is 22. Okay, so that means we have 22 nickels. And we take the 22, we multiply it by 2, and we get 44 dimes. Okay, and we could take the 22 and divide by 2, and we get 11 quarters. Okay, and do a quick check. Does my answer make sense? Do I have 77 coins? Yep, I have 77 coins. All right. Okay, so moving on to number 5. And at any point, guys, please pause this video, go back, and review. The second of 2 numbers is 4 times the first. Their sum is 45. Find the numbers. So you have 2 numbers. The second one is 4 times the first. So since we can write an expression for the second number, let's let f be the first. Okay, if f is the first, the second is going to be 4f. Their sum means addition, so we're going to take the first, add the second, and we get 45. So when we do this, this is actually an easy problem. 5f is equal to 45. We divide by 5, and our first is going to be equal to 9. Okay? If our first is 9, what is the second? Well, it's 4 times 9. We just plug it in, and we get 36. So our 2 numbers are 9 and 36. Did they add up to 45? Yep. Okay. The next problem has to deal with perimeter. Okay. The length of a rectangle is 7 centimeters greater than a width. Anytime I have a shape, I like to draw a picture. Okay. All right. Since the length is 7 centimeters greater than the width, let's let W be the width. And I can write an expression for the length based upon the width. So my length, again, using just one variable, the length would be 7 centimeters greater, so that would be W plus 7. Okay? The perimeter, so now let's see, we've got the width as being W, all right, and our length is W plus 7. Okay, so this is what my picture might look like. The perimeter, you just add up all the sides. Okay, so I could take W plus 7 plus W again, plus W plus 7. So I just took the 4 sides and added them up, and I would get 54. Or I could count 1, 2, 3, 4 W's plus 14 equals 54. So this becomes an easy problem to solve. So then I subtract my 14. 4W is going to be equal to 40. And then when I take my 4W equals 40, I'm going to divide by 4. I'm going to find out my width is actually equal to 10 centimeters. If my width is 10 centimeters, my length is going to be 10 plus 7, or 17 centimeters. So there's my width and my length. Okay, I'm going to pause this video right here and continue in a second video because I am limited to 15 minutes.